Hi everybody, this video is going to cover lesson 1.5 and we're going to talk about inverses of functions. So first of all we have to talk about what is an inverse. And an inverse is an operation that operations that undo each other. Like multiplication is the inverse of division, subtraction is the inverse of addition. Well, functions also have inverses. And so we need to figure out, okay, how is this idea of undoing each other or opposites of each other, because these are opposites, right? How can we apply that to functions? Let's look at a couple graphs. So here we have a couple of graphs, and these are examples of inverse functions. It says the solid line is the original function f of x, and the dotted line is the inverse function, or g of x. So maybe we should label this. This one is your f of x function, and this is your g of x function. Same thing over here. This is your f of x function, and this is your g of x function. And they say that the original is the f of x and the g of x is the inverse of that function. What do you notice about the graphs? Take a few seconds to look at these, pause the video, and write down what are some things that you notice about the graphs. Okay, here are a couple things that you might have written down, although you might have other stuff too. One thing is reflected across the line y equals x, and you might wonder, what does that even mean? Well, the line y equals x, let me show you where that's going to be. The line y equals x is this line right here. It starts at 0, 0, it goes up 1 over 1, up 1 over 1, up 1 over 1, etc. So this is the line y equals x. Can you see that this function is reflected across that line? It's a perfect reflection across that line. So that's one thing. Or you could say it's the same shape but different orientation. And so these two shapes, they're the same exact shape, it's just they're kind of flipped a little bit. Same thing here. I'm going to draw in that line of y equals x is going to go through here. And so again, you might be able to see that it's reflected across that line. And this one, that orientation thing is very easy to see here. It's the same exact parabola, but here it is, and then it kind of flips it sideways. So that is what we mean by inverse functions. Now you might have other things written down here too, and that's great, and we will talk about that tomorrow in class of what else you could write down. So the next thing I want you to do is what we just said were some observations about the inverses. Will you take a minute now and create a table of values from, I said table of points, a table of values from the function inverse. So do this for each graph. So in other words, here's the point 2, 0, here's the point 4, 1, here's the point 6, 4, etc., etc. Will you take a minute and put those in your XY tables that are listed here? Okay, here's what I came up with. I filled in my tables of values with these numbers. Let's take a look. Do you see that the y values, or f of x values here, match with the x values here? And the x values here match with the y values, or the g of x values here. Same thing happens here. What was an x is now a y, and what was a y is now an x. So that is another characteristic of inverses of functions, is that they switch their x and their y values. So the x and the y, or if we want to call that f of x, we could, they are switched with each other. And that is really the same thing. When we said reflected across the line y equals x, look at that line, y equals x. And here we're saying the same thing. We're saying we're switched our x with our y. So we changed our x into a y. So that's kind of saying a similar thing. What does this mean for the relationship between domain and range? Well, remember that domain is our x values and range is our y values. So if we've switched the x with the y, then haven't we also switched the domain and range? Okay, and so that's another thing that's important to recognize about when we talk about inverses of functions, that their domains and ranges are switched. One last thing is this concept of one-to-one, or also called invertible. And I use this word invertible because that's a word that sometimes people use on tests, like standardized tests, like MAP tests or ACT or things like that. But in this class, we will usually call it one-to-one. And so this is a question of are things are a one-to-one function. So if we look at this, this is not a one-to-one function. And I'll tell you why it's not a one-to-one function. That is, do you see how the 4 repeats and the 1 repeats? And so it's not one-to-one. A one-to-one function has exactly 1x for every y. So this is not a one-to-one function. Now it is a function because nothing in the x's repeats, but it's not a one-to-one function. A one-to-one function would be like if we had these numbers over here and let's say it went 9, 7, 5, 3, 1. Now that is one-to-one because nothing is repeating the x's, so it is a function, and nothing is repeating in the y's, so it's one-to-one. Remember that definition of like when you have like an x column and a y column, and if this goes to this, then that's not a function. But what we're saying now is even if you have this going to 2 different things, that is not a one-to-one function. It's just a little more specific. And one-to-one just means it's 1 for every 1, right? They match up 1-to-1 exactly. Okay, let's turn the page. And I see that my formatting got kind of thrown off here, so sorry about that. So in order for the inverse to be a function, the original function must pass the horizontal line test. And in some of our classes, we talked about, is there such a thing? And this is a thing, horizontal line test. If a horizontal line intersects a function's graph more than once, then the function is not one-to-one. So it's just another way, just like a minute ago we were talking about, like, that thing where, okay, if it goes here and here, or if it goes here and here, that's not one-to-one. I'm going to erase that. Then similar, can do it that way with a table, but we can also look at a graph. And so, for instance, I could use a horizontal line test, and I could say that this is not one-to-one. And the reason it's not one-to-one is because it's hitting the graph more than once. It hits it here, and it hits it here. It's still a function. But what this says is if I invert this, and remember we had this a minute ago, that the inverted function will look something like this. Now this is not a function, okay? And this one, think of our horizontal line test. If we draw this horizontal line, is that line going to hit more than once anywhere I go? No, it's not. This one is one-to-one because it passes the horizontal line test. And maybe over in this one we should say that it doesn't pass the HLT. Okay, when we are looking at inverses, we are typically looking at, does it reflect over the line y equals x? This one, it does appear that they are inverses because it does reflect over the line y equals x. So I'm going to write for A, and I'm kind of out of space, so I'll come over here. I'm going to say yes, it does reflect over y equals x. Notice, is it one-to-one? No, it's not one-to-one. Why not? Because it does not pass the horizontal line test. Let's take a look at this one. Is this an inverse? No, it is not an inverse. Why not? Well, it does not reflect over the line y equals x. It does reflect, but it reflects over the axis. And that's not what we're asking for here. We're asking for it has to be that y equals x. So since it does not, then it's not they are not inverses of each other. So it doesn't reflect over y equals x. Okay, so you should be able to look at a graph and decide whether or not it is an inverse. One more with graphs with coordinates and a table is what I want you to do is I want you to reflect this. And so it probably will help if you put that into, draw your line of y equals x. I need to get rid of that. So I'm going to go down here to the point -6, 6, and I'm going to connect it to the point +6, 6. So here's my line of reflection. I need to reflect this image over this line. Well, how do I do that? Well, the first thing is you need to make a table of values for the original function. So I did that. I looked here and I figured out what it was. Now, if that is my original, then what is going to be the table of the inverse? Take a second here, pause the video, and fill in your inverse table. Okay, I've come up with my table. Now I need to put these coordinates onto this graph. So I'm going to take a second to graph that. Do it. Pause the video here, take a second to graph it. All right, you should have points that look something like this. And now we need to make that kind of that W shape that it is. And it's, for me, it's a little bit hard to draw on my board, but I'm going to try my best. Try to connect these points and make this W shape. Okay, I told you mine wasn't great, but I did the best I could. So here we have a function. We figured out the table, we switch the table, and we get the inverse. This is an inverse. Okay, other question, is it 1-to-1? No, it's not 1-to-1. How do I know? Does not pass the horizontal line test. Okay, so it's not 1-to-1, but they are inverses. Okay, take a few minutes. If you haven't written down any questions write them down in the margin. And what do we need to remember about inverses? Write a couple things down here that we need to remember about inverses, and we will talk about inverses in class tomorrow.